All right. 6.3c, square root verifying inverses. It's going to be on page 128 of your handy dandy notebook. Did you not get out of the basket? I did. Nope, y'all used it all. How do y'all be students with no supplies? Yira? Well, if that's what you need, then you need to buy it. All right. So we are going to talk about how to verify inverses. And we verify inverses by the process called, I just had a brain fart. Composition. There we go. Composition. So through composition, we did composition in the first 6 weeks of school, but we only did it with numbers, not with functions. Now we're doing it with a function. So basically, that's where you plug a number into one function, then the answer of that one into the next one, right? So basically, you know how people are like, oh, you can't turn apples into oranges? Ha, 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 ha. Yeah, you can with composition. So with composition, it's saying you take your apples, you're gonna plug it into the first function. They make a whole new thing. We're gonna call them lemons. Then you take the lemons and you're gonna plug them into the other function, and wham, bam, thank you, ma'am. You somehow have oranges, okay? That's how composition works. Okay, now, why is composition important? Because it lets us know if two functions are inverses of each other. So if I take f of x and I substitute g of x in and I get x, or if I take g of x and I substitute f of x in and I get x, that means the two functions are inverses. And it sounds weird, but
Ain't you recording me, John? Where did this go?
at the top of your page somewhere.
Oh.
All right, so that's our goal. We're going to verify whether substituting g of x into f equals x and substituting f of x into g equals x. If they do, then they are inverses. If they don't, then they are not. Okay, so here we go. We have x squared plus 7 with a domain restriction. The domain restriction lets us know that the inverse is a function if it works. Now, if we have the quadratic with no domain restriction, no bueno. Because that means it wouldn't be a function, it would just be a relation. So we're going to split this in half. We're going to do f of g of x on one side, and we're going to do g of f of x on the other side. Huh? So g of x, what does g of x equal? It equals the square root of x minus 7. So we're substituting in the square root of x minus 7 everywhere that there's an x. Okay, so that equals square root of x minus 7 squared plus 7. All right. What does the square and the square root, what is their relationship? What do they do to each other? They cancel out because they're inverses, right? So this is going to go away, and we're just left with x minus 7 plus 7. What happens to negative 7 and positive 7? They cancel out. So we're just left with x. So what does that mean about f of x and g of x? That they are inverses. That's what that means. When it's just x left, that means that they're inverses. Okay, and you could do it either as f of g of x or g as f of x. So doing it the other way, this time we're plugging in f of x in for x of g of x. So g composed of x squared plus 7 equals the square root of x squared plus 7 minus 7. I have a positive 7 and a negative 7, so they,
So if it's x squared, is that an inverse too?
so we have square root and x squared, and what do they do? Cancel out, and what are we left with? X. So what does that verify again? That they are inverses.
So Ms. Jones.
Yes,
the
yes.
answer will never be x squared.
It can be, and if it is x squared, then that means they are
Inverse.
not inverses.
I asked you that, you said they was.
If it comes out to be x,
X squared.
No, it has to just be x. Only x. You confuse me. All right, so I would like for you guys to try this one. So choose either one. So choose whether you're going to use f composed of g of x or g composed of f of x.
Also, we can choose either.
Yes. Okay, I'm going to be a nice person this year, and yes, normally I would make you do both. So here, we're substituting in g of x, which is the square root of x plus 1, which equals, where x is, it now becomes parentheses, square root of x plus 1 minus 1 squared. Your ones cancel out, and you're left with square root of x squared. Your square and your root cancel out, and you're left with, so are they inverses? Yes. Good job. Now, just in case someone does this one, you're substituting f of x, so this guy. And that's x minus 1 squared being substituted in. So you have the square root of x minus 1 squared plus 1. This time, the root and power cancel out first. And you're left with x minus 1 plus 1. Then your ones cancel out. And you're left with x. So either way, are they inverses? Yes. How do you feel about verifying inverses? Doable? Okay, cool. So the last three, we're going to apply 6A, 6.3A and 6.3B notes. Okay, we're gonna do the other ones first, the first part first together, and then you're gonna find the inverse and find the domain and range of the inverse, okay? But we're gonna find the domain and range of the current function together using our previous skills. Cool? So we're gonna start with number 1. So number 1, we have y equals x squared minus 6, okay? Because I have x squared minus 6, I know that this is a quadratic, and it looks something like this, right? Because my a is positive. Now, in order to find the domain and range of a quadratic, you need to know its vertex. So we're going to have this quadratic, and its vertex is based off of its h and k. If I do not have an h, what does that mean the value of my h is? 0. What is my k? -6. So my vertex is at 0, -6. In order for this to have an inverse, there has to be a domain restriction. So what is the smallest my domain can be? 0. And then it continues to infinity. My range would be what? What's the smallest my range is? -6 to infinity. Okay. And then I'm gonna pause and let you guys do the inverse and the domain and range of the inverse, okay? So pause and then we'll come back. All right, so once you have the original, you then can talk about the inverse. So the inverse here, remember, that's you switching your y and your x. And when you switch your y and your x, you're asking yourself, what do you need to do to get y by itself? So we have x equals y squared minus 6. So in order to get y by itself, to get my inverse, that means we are adding 6 and we're taking the square root. Okay, and so that this is a function, we're going to have restrictions, and our domain and our range is based off of our original. So the domain here comes from the range of the original, which is -6 to infinity. And our range here comes from the original, which was a restricted domain of 0 to infinity. Okay. Okay, now pause, and you're going to try to do number 2. Thank you for pausing. Now we're back. So we're going to look at the original. This is a square root function. So square root functions don't have a vertex necessarily. They have a starting point. So where does this square root function start at? Well, based off of your h and your k, it starts at 0, 2, and our a is positive, so it's doing this. Could you graph it and see that? Yes, you could. The domain here, the domain starts at 0 and goes to infinity. The range here starts at 2 and goes to infinity. All right, so you're going to pause, and you're going to find the inverse and then state the domain and range of the inverse. Okay, welcome back. So the inverse, we're going to switch our x and y. So we have x equals 3, absolute value of y plus 2. And to find your inverse, you're asking yourself, what do I need to do to get y by itself? Well, first, I have to subtract 2. Second, I have to divide 3. And third, I have to take the square of all of this because it's all there. Okay, so there's my inverse. And the domain of my inverse comes from the range of my original, which is 2 to infinity. And the range of my inverse comes from the restricted, not restricted, well, the domain, it's my restricted domain of this function, which is, sorry, what was the domain here is the range here. Forget the word restriction. Don't know why I said it. I need food, sleep, nap, probably. Okay, then last one. Again, we have another square root. So we don't have a vertex, but we do have a starting point. This time, we have our positive a. There's nothing there, so it's positive 1. And our h is, remember, x's are liars. So it looks like it's a positive 5, but it's actually a negative 5. And there's no k, so it's plus 0. So we start here. So therefore, our domain is from -5 to infinity. And our range is from 0 to infinity. All right, so we're going to pause, and I'm going to let you find the inverse. Okay, welcome back. Your inverse, we're going to switch our x and our y. So we have x equals the square root of y plus 5. To get our inverse, to get y by itself, the first thing we have to do is square. Then the last thing we're going to do is subtract 5. So our inverse is x squared minus 5. The domain of our inverse comes from the range of our original, which is 0 to infinity. The range of our inverse comes from the domain of our original, which is -5 to infinity. And bam, that concludes our section on inverse. If you have questions, let me know. We will go over the classwork. Well, we will do the classwork when we come back after spring break. So don't worry about doing any of the classwork. Enjoy your spring break. Be safe, have fun, and make good choices.